AutoGen is here and it is incredible. AutoGen is a project by Microsoft that allows you to create as many autonomous agents as you want and have them work together to do things. And it's a framework, so it's incredibly flexible. You can define all the different agents that you want, the roles you want them to embody, and then just send them off working together. And of course, you can work with them. So today, I'm going to tell you a little bit about it, then I'm going to show you how to install it, then I'm going to show you how to use it. Let's go. So this is the blog post announcing AutoGen by Microsoft. AutoGen enabling next generation large language model applications. So AutoGen allows you to do what a lot of projects are already doing manually, which is have multiple agents working together to accomplish a task. And what I've seen and what everyone has really seen is that when you have multiple AI agents working together, the output tends to be much better, whether you're talking about coding or whether you're talking about planning, creative writing, everything. Because you have one agent that is doing the work, another agent that can check the work, another that can provide feedback, and they go through this iterative loop where the final output just becomes so much better. And AutoGen can be dropped into any project. And it also is a drop-in replacement for OpenAI's APIs. So you can simply drop in multi-agent support without changing your code if you have an existing code base using OpenAI's API. And so I want to read this part here because it really summarizes what AutoGen does really well. AutoGen is a framework for simplifying the orchestration, optimization, and automation of LLM workflows. It offers customizable and conversable agents that leverage the strongest capabilities of the most advanced LLMs like GPT-4, while addressing their limitations by integrating with humans and tools and having conversations between multiple agents via automated chat. Now, the nice thing is it doesn't completely depend on OpenAI's API, and obviously it's super easy to use with it, but technically, you can drop in any large language model with this framework as long as it has an API. So here it says, with AutoGen, building a complex multi-agent conversation system boils down to defining a set of agents with specialized capabilities and roles. So for example, if we're building an engineering team out of AI agents, we might have one that's an engineer, another that's a project manager, another that's quality assurance, and so on. And then you define the interaction behavior between agents, i.e., what to reply when an agent receives a message from another agent. So not only are you defining the agents and roles, but you're actually defining how they work together. And I'm just going to turn off my dark reader just so I can show you this chart. So in this example that they give, they show the two default agents that AutoGen comes with. Number one is a user proxy agent. And that is essentially an AI agent that works on behalf of the user. So it can make decisions and it can also ask the user, the actual human, for input, but it can also do things on its own. So for example, if one of the engineering agents creates some code, it'll send it to the user proxy agent who can then either send it to the human for approval to run the code, or it can auto approve and run the code itself. Then we also have this assistant agent, which is just kind of the most default version of an agent that you can have. And the assistant agent is the one that is actually going to be writing the code in the example that we just discussed. So here it says a user proxy agent and assistant agent from AutoGen can be used to build an enhanced version of ChatGPT plus Code Interpreter plus plugins. The assistant agent plays the role of an AI assistant like Bing Chat or ChatGPT. The user proxy agent plays the role of the user and simulates users' behavior, such as code execution. So if that user proxy agent weren't there, the assistant agent would pass me the code, and then I would open up Visual Studio Code, for example, and just run the code. But now that we have that user proxy agent, the user proxy agent can actually run the code itself, saving me time. AutoGen automates the chat between two agents while allowing human feedback or intervention. The user proxy seamlessly engages humans and uses tools when appropriate. So another thing it can do is ask me for input. So as all of these autonomous agents are working together, at any point I can say, okay, this is the point in which you want to ask the user, the human, for input as part of this process. Now on the GitHub page for AutoGen, they give a bunch of different examples and the code for them using Google Colab. And so we're going to review a couple of these as the way to teach ourselves how to use it. So the first one says automated task solving with code generation, execution, and debugging. That sounds like a great one. Let's try that one. Okay, so I have my Google Colab loaded up. This is the templated example that Microsoft provides. I'll drop a link in the description of all of these examples that we go over today. So it says, in this notebook, we demonstrate how to use assistant agent and user proxy agent to write code and execute the code. Here, assistant agent is an LLM-based agent that can write Python code. code in a Python coding block for a user to execute for a given task. So this is essentially Code Interpreter, but on steroids. And if you remember, as you're using Code Interpreter, if it runs into any problems, for example, if it writes some code and it gets an error or a bug, it can iteratively fix itself. And that's the beauty of the multi-agent framework. User proxy agent is an agent which serves as a proxy for the human user to execute the code written by assistant agent or automatically execute the code. So again, usually if there were code output, I would have to copy the code, put it in Visual Studio Code, and then execute it. But in this example, user proxy agent can actually run the code for me. And it can either ask for my approval to run the code, or it can just run the code automatically. And there's a setting for that, which I'll show you. Depending on the setting of human input mode, and that's where we set whether you need to actually give approval or not, and max consecutive auto reply, the user proxy agent either solicits feedback from the human user or returns auto feedback based on the result of code execution, success or failures, and corresponding outputs. Then assistant agent will debug the code and suggest new code if the result contains error. The two agents keep communicating with each other until the task is done. So I'm going to be showing you all of this through Google Colab, but you can easily run this locally as well. The first step is right here. We're just going to install the AutoGen library. So pip install AutoGen. So I just removed the commenting and then I installed AutoGen. Next, we're going to set our API endpoint. And this is where you can plug in other APIs. If you want to see me create another video where I show you how to use Llama 2 specifically with AutoGen, let me know in the comments. So here we just import the library, import AutoGen, and then we're going to have a config list. And we say AutoGen config list from JSON, and then we pass in a JSON object. OAI config list is just the name. And then we have the filters. So we're saying the model can be any of these models. And here's what the config list looks like. And you can have multiple API endpoints. So you can actually use multiple models, it seems. So here we have model GPT-4, and we're going to input our API key right here. So I go to OpenAI again, and I go to the API keys section. And if you don't already have an OpenAI account, go ahead and sign up, click create new key. And I'm going to type in AutoGen as the name and create new key. And don't worry, I am going to revoke this API key before publishing the video. So I copy it. And one quick change that I made is adding this config list JSON object into this code block right here, because I realized that it can't actually read from this. This is just text. Now I run this and it's going to import AutoGen, and then it's going to set up the configuration for me. Okay, should be done. And so here it is, example task, check stock price change. And so what this is going to need to do is actually write code to go check the stock prices and then present it to me, the user. So here's where we're going to be defining our different agents. The first agent is the standard agent, the assistant. And so we say assistant agent, that's one of the standard agents, AutoGen.assistant agent, name assistant, LLM config, and this is where we actually write some configuration about our LLM. We use seed 42, and seed is for caching. So it actually tries to cache some of these prompts that it's going to be using. So if we have 42 over and over again, it will not actually call the LLM again and again. It'll just use the cached version. Then we pass in the config list, and then the config list reads from the config file, and then we have the temperature. And of course, as always, the higher the temperature, the more creative the result, and the lower the temperature, the more standardized or less unique the result is going to be. Then we also have the user proxy agent. And as a reminder, the user proxy agent represents the user, so represents me, the human user, but it can also do things on its own. So here we call it user proxy. The human input mode is never, and so that means it's just going to execute code as it gets it. It's not going to ask me for approval. And so really quickly here, it says the human input mode options are always, so basically at every single step, ask for input. Terminate, which means only during termination does it ask for input, only when it's done. And then never, which means don't ever ask for input from the user. Max consecutive auto reply now is set at 10, and that essentially means the number of back and forths that we're going to allow before the task terminates. So 10 is fine. Obviously, the larger it is, the more you risk the agents going back and forth without any human input. Then here we say what the is termination message is. And this is just really the logic to understand when the termination actually occurs, when the task has been completed. Then we have the code execution config. So we have the working directory coding. Then we say use Docker false, so it can use Docker. And then here's where we actually kick off the dialogue. So it says user proxy, and it always starts with user proxy, initiate chat. And we're going to initiate chat with an assistant with the message, What date is today? Compare the year-to-date gain for Meta and Tesla. And so that is the task that we're giving it. And keep in mind, you can define as many agents as you want to work together, and you can give them all individual unique roles. So now we run it, and there it is. It's going. What date is today? This is the user proxy. This is me asking it. This is if I were to prompt the large language model. What date is today? Compare the year-to-date gain for Meta and Tesla. So it is figuring out how to do that. Most likely, it's going to have to search the web for that information of what the stock prices are. And then it's going to maybe put together a graph or just tell me. All right, here it goes. So the assistant to the user proxy, remember, this is a conversation. First, let's get the current date using Python. So it writes some Python code to get the date, and today equals date.today. That's fine, and it prints the date. Next, we need to get the year-to-date gain for Meta and Tesla. We can use the Y-Finance library in Python to get the stock prices. Please install the library if you haven't done so by running pip install Y-Finance in your terminal. So this is the assistant telling me to install that library. However, the user agent is going to jump in and do that for me. And it actually gives me the code. Here is the Python code to get the year-to-date gain for Meta and Tesla. So it writes the code, import Y-Finance from date time, import date time, get the current year. There it's using that library. So it actually wrote the code. And here it says this code will print the year-to-date gain for Meta and Tesla in percentage. Now, here's where the execution actually occurs. So this is the user proxy, aka me, but an agent on my behalf executing the code. And we got a bug. So here we have a bug and we pass it back. See, it says user proxy to the assistant. We pass that issue back to the assistant to try to fix it. And here it is, the assistant back to the user. I apologize for the oversight. The variable today was defined in the first code block, but not in the second one. Let's correct it. So there it is. It is actually correcting it. Here we go. Here's the new code. And here's the code output. So it looks like it actually worked this time. There it is. Meta year-to-date gain, Tesla year-to-date gain in percentage. And then the assistant back to the user says, great, the code has been executed successfully. And then the assistant basically packages up the information in a really nice readable way. So as of October 2nd, 2023, that is today, the year-to-date gain for Meta is approximately 140%, and the year-to-date gain for Tesla is 131%. This means if you had invested in these stocks at the beginning of the year, your investment in Meta would have increased by about 140%, and your investment in Tesla would have increased by 131%. Please note that stock prices can fluctuate and the actual gains may vary. Terminate. Now, the assistant knew it completed it successfully, and then it output the terminate response, which stops the conversation completely. This is incredible. It's a very simple example, but it really shows you the power of AutoGen. Let's say we want to actually plot a chart. So let's continue. We have user proxy sending a message. The recipient is going to be the assistant. Plot a chart of their stock price change year to date and save to stock price ytd.png. Let's run that. We're just continuing the conversation. We don't have to restart the entire prompt. So first, the user proxy, me, to assistant. And then it's saying what this prompt is. Okay, let's take a look at what the output is. So assistant to the user. Sure, we can use matplotlib library in Python to plot the chart. If you haven't installed it already, you can install it by running pip install matplotlib. We don't have to do that. The user proxy agent is going to do that on our behalf. And the assistant writes the code for us. So here we go. We're going to import it. It also tells us how to install it. And then it shows how to actually output the data in a chart format. And we have an error. So metadata normalized, name metadata is not defined. So the user is going to pass the error to the assistant. Then the assistant back to the user says, I apologize for the oversight. The variables metadata and Tesla data were defined in the previous code block, but not in this one. Let's correct it. And here we go. We have updated code now. Then it runs it again. User proxy to assistant. It actually completed it that time. Excellent. Okay, now we have stock price ytd.png. And now let's display the generated file. Let's go ahead and do it. So I just ran this. This is fresh from the code that I just ran, and it worked. This is absolutely incredible. How amazing is that? Now anybody can create a multi-agent environment so easily. I want to show one more example because this one is so cool. This next one is auto-generated agent chat teaching. This notebook demonstrates how AutoGen enables a user to teach AI new skills via natural agent interactions without requiring knowledge of a programming language. So basically what we're going to do is we're going to create new skills for these agents that they can use over and over again. So as always, we're going to start with pip install AutoGen. So right here, I'm going to go ahead, remove the comment, and then run it. All right, there we're done. Now we're going to set our API endpoint. We're going to import AutoGen. We're going to set up the LLM config. All right, so I just changed a couple things in here. We're going to do it simply instead of having a separate file. I'm just going to put this config list right here. Then we load the config list into this LLM config. Hit play. Then let's run this block. Done. Example task, literature survey. We consider a scenario where one needs to find research papers of a certain topic, categorize the application domains, and plot a bar chart of the number of papers in each domain. So first, we're going to construct our agents. Here we have an assistant agent and we have the user proxy agent just like normal. And there we go. We set them up. And let's run this block. Done. Now we do step-by-step requests. So here we say find ARXIV papers that show how are people studying trust, calibration, and AI-based systems. And there we go. Now, of course, you can define all of this in separate files and then load the files, but we're going to do it simply by just including it in the code. And here we go. Find ARXIV papers that show how are people studying trust, calibration, and AI-based systems. And the user is initiating the chat. And now the assistant is probably working with that. Here we go. To find ARXIV papers related to trust calibration in AI-based systems, we can use the ARXIV API. So it has no information about what the ARXIV API actually looks like, but it's going to assume some stuff, and here we go. So it writes some code to do that. Here it is, the export right there, and it's basically just going to scrape that. It's going to tell me everything I need to do. Then the user proxy is going to actually execute the code, and here we go. It looks like it's actually grabbing some papers. This is absolutely so cool. And here we grab a bunch of different papers. The Python script has successfully fetched the information about ARXIV papers related to trust calibration in AI-based systems. Here are the titles of the paper, their authors, a brief summary, and a link to the full paper. So it looks like we got a list of 10, and we can actually click into each of them if we wanted to. Then we got the terminate command. So far what we have is a list. Then we continue the task. Task 2, analyze the above results to list the application domains studied by these papers. Let's do that. So it's probably going to actually need to read the papers. So let's see how it decides to do that. Okay, here we go. Assistant. Based on the summaries of the papers, here are the application domains that these papers have studied. I'm not actually sure how it analyzed the papers. I would think it would have to write some code to actually go analyze the papers, but maybe it just read the summaries. Okay, so now we have the summaries. Then task 3, use this data to generate a bar chart of domains and number of papers in that domain and save to a file. Do that now. Now the assistant says to generate a bar chart of the application domains and the number of papers in each domain, we can use matplotlib library in Python. Here's the script. So it provides us the script. Perfect. Then the user proxy executes the code, and it looks like it executed it successfully on the first try. And terminate. The Python script has successfully generated a bar chart showing the number. There we go. Now let's uncomment this and let's look at the bar chart. Okay, so it looks like it named it something different. So I'm going to grab that name and I'm going to put it right here and let's play it again. There we go. Unbelievable. That was easy. Okay, now we're done. Next, we're actually going to create a recipe, basically a learning, a piece of knowledge that can be used over and over again to do something very similar. Now that the task has finished via a number of interactions, the user does not want to repeat these many steps in the future. What can the user do? A follow-up request can be made to create a reusable recipe. So task 4, reflect on the sequence and create a recipe containing all the steps necessary and a name for it. Suggest well-documented, generalized Python functions to perform similar tasks for the coding steps in the future. Make sure the coding steps and non-coding steps are never mixed in one function. All right, let's see if it works. I mean, it's so cool. It's so meta. Not Facebook meta, but actually meta. And once we have this, we could technically store it locally and we're caching some of it. So this actually becomes extremely efficient to run. Okay, here we go. Sure, let's create a recipe for the sequence of steps as followed. And it lists out the sequence of steps and it returns all of this code. Beautiful, great. It seems like Python functions for fetching papers from ARXIV and generating a bar chart have been defined successfully. You can use these functions in the future to perform similar tasks. Remember to perform the non-coding steps manually in your language. Okay, terminate, done. Now we can reuse the recipes if we wanted to, but I'm gonna go ahead and skip that step. So that's it. If your mind isn't blown by this, I don't know what's gonna blow your mind. This is absolutely incredible, and I'm just scratching the surface. Let me know in the comments if you have use cases that you want me to explore with this that I didn't touch on today. If you liked this video, please consider giving a like and subscribe, and I'll see you in the next one.